Polynomials. And so up here, we're going to talk about what simplifying a polynomial means. Okay, and so it says to simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. Okay, so basically our answers have no parentheses and no negative exponents. And so when we're starting to talk about exponents, we have some rules of exponents. And these are what you need to know. And you might already know these, you might not. These are actually taken from your book, and you're going to be responsible for these, on these rules of exponents. Okay? So the first one, if you have a product of powers, which basically means you have the same base and exponents, what you do is you add the exponents together. So example, 3 squared times 3 to the 4th equals 3 to the 6th power. You add the 2 and the 4. Okay? Why is that? Well, 3 squared means 3 times 3. 3 to the 4th means 3 times 3 times 3 times 3. And if you look at those, how many 3's do you have? 6. So that's where the 6 comes from. You just add those together. The quotient of powers. Okay, same thought, except for instead of adding exponents, you subtract them. And once again, if you forgot that come test time, you have 9 to the 5th, which means 9 times 9 times 9 times 9 times 9, all divided by 9 times 9. What you can do is you can actually cancel out 2 of the 9's. And so then that leaves you with 9 to the 3rd power. A negative exponent, basically what that means is that's going to go in the opposite location. So if it's negative in the numerator, you put it in the denominator. If it's in the denominator, you put it in the numerator. So let's go ahead and talk about a power of a power. Okay. So, a power of a power, x to the a, all raised to the b power. What you do with those is you multiply the 2. The power of a product, basically I'm distributing that a to each. And the power of a quotient, once again you're distributing it. And then finally the 0 power. Anything to the 0 power is always 1. So once again, these are in your book. Okay, so you can go ahead and look at those, and if you need to write them in your notes, you can. But those are on page 303 in your book. We're going to go ahead and jump right in with another thought here on simplified monomials. A monomial expression is in simplified form when there are no powers of powers, each base appears exactly once, all fractions are in simplest form, and there are no negative exponents. So those 4 things need to happen in every one of your answers. And this is something that when we go through these, you'll already pretty much know. Okay? Know that these are the 4 things. So let's go ahead and start with an example. It says simplify each expression, assume that no variable equals 0. Okay? So this is our problem, and we're going to go through a step-by-step process that really works. So the first thing you're going to focus on, at least in this problem, so you're going to focus on the coefficients. So I'm looking specifically at the numbers. I have 2 and I have 3, so I'm going to multiply those together and I get 6. Now I'm going to focus on the a's. A to the negative 2nd, a cubed. What do you do with the negative 2 and the 3? You add them. And so what is negative 2 plus 3? 1. So it's just a. Now I'm going to go to my next variable, which is b squared. Is there another b? No, so I'm going to put b squared. Then I'm going to go to my next variable. What's my next variable? C to the negative 2nd. And we are almost done, except for one of the things you cannot have is a negative exponent. So I've got to somehow get rid of that negative 2 and make it a positive 2. So if you remember the thing with negative exponents, in order to make them positive, I'm going to put them in the other location. So since this is in the numerator, to make it positive, I'm going to put it in the denominator. And so my final answer will be 6ab squared all over c squared. And that's your answer. Not too much. Oops. Keep skipping today. So we're going to look at some more here. These are going to entail division. So I have q squared r to the 4th over q to the 7th r cubed. Now, first we could actually subtract the exponents. That could be one thing we could do. Or I'm going to show you another technique that works. Okay? I have fractions here. And so I'm going to visually think about what this means. If I look at my q's, what q squared means is that there's 2 q's on the top. Q to the 7th means there's 7 on the bottom. So there's going to be some that cancel out, right? How many are going to be left? 5. Where at? So that is where q to the 5th belongs. Okay. So let's look at the r's. R to the 4th means I have 4 r's on the top, right? R cubed means I have 3 r's on the bottom. What is my net result going to be? R where? On the top. And that is your final answer. So that is one way of viewing that. Yes, you could subtract, in which case if I took 2 minus 7, I'm going to get q to the negative 5th. 4 minus 3, I'm going to get r to the 1st, which is the exact same thing as what we found. Let's look at the next one. What do you think my first step is going to be to do on this next problem? Not times. Distribute, and I'm going to distribute the power. So that power is actually going to go to every term. And that's not like a 3, it's just a power to the 3rd. So really what that means is that I have negative 2 cubed. I have a to the 4th cubed. I have b squared cubed. So what is negative 2 cubed? Negative, negative, negative. So negative 2 times negative 2 times negative 2. Negative 8. What do I do with the 4 and the 3 here? Multiply them. And what do I get? To the 12th over b to the 6th. Now here's how you know you multiply. A to the 4th cubed means a to the 4th times a to the 4th times a to the 4th, right? So really 4a's, 4a's, and 4a's makes 12a's. Oh, got it. Skipping. So now we're going to be looking at a lot of examples. And the reason why we look at a lot of examples is because there's a lot of things you can do with polynomials.
All 15 slides examples.
So let's go ahead and look at the first numbers, because I'm going to start with the 2 and the negative 7. So I have 2 and negative 7. What does that give me? Negative 14. Now I'm going to work my way to the right. X to the negative 3rd, x to the 5th. What does that give me?
X squared on top.
X squared. Y cubed, y to the negative 6th. What does that give me?
Y cubed on bottom.
Y to the negative 3rd, and then we'll simplify. Okay, because basically we're adding the 3 and the negative 6. And so in order to now rewrite that negative exponent so it doesn't appear negative, I'm going to put that answer in the denominator.
It's okay if the top 14, it's okay if that's called a negative.
That's a negative 14a number. It's not an exponent that's negative. And so that's why you can still have that. Oh, let's go back.
All 15 is wrong.
So we have a to the 4th, or a over 4 raised to the negative 3rd power. So what do you do with the negative? 3. I'm going to distribute that to each. That's one option. So really I have a to the negative 3rd over 4 to the negative 3rd. Well, you know you can't have that negative exponent. So where am I going to put the a to the negative 3rd? In the bottom. Where am I going to put the 4 to the negative 3rd? On the top, so that becomes 4 cubed. You're not quite done yet. Why are you not quite done? Yep, simplify. What is 4 cubed? 4 times 4 times 4.
Wow.
Close.
64.
64 over a cubed.
All right.
All right, so this one, once again, we're going to work left to right. So I have 15 c to the 5th d cubed over negative 3 c squared d to the 7th. So now I'm going to start with the 15 and the negative 3. What is 15 divided by negative 3? Negative 5. So now I need to envision I have c to the 5th, which means 5 c's, over 2 c's. Net result is 3 c's where? On the top. Let's look at the next one, the d's. What am I going to get? Okay, so 3 d's on the top, 7 d's on the bottom. D to the what? Could I just put d to the 4th on the bottom? Okay. And there you go. So now that's a little bit with just simplified exponents. This is something that you will see on the NESA statewide assessment. Okay, now we're going to talk about degrees. And this is something that is not a tough concept. Basically, the degree of a polynomial is the power of the term with the highest power. Power of the term with the highest power. And so now what we're going to do is we're going to look at a few examples of polynomials and whether or not things are polynomials. And so if you notice here it says determine whether each expression is a polynomial. If it is a polynomial, state the degree of a polynomial. So here's what a polynomial is in a nutshell. Okay? My variables are all positive. Okay? I've either added or subtracted the variables. I never divide the variables. I also never take the square root of a variable. Okay? All the exponents must be whole numbers. So with that in mind, does this kind of fit those things that I said? So this would be a polynomial. Okay? I know the 1/4 is a fraction, I get that, but there are no variables in the fraction, so we're okay. So now it says state, so yes, it's a polynomial. I need to state the degree of the polynomial. So the degree is the term with the highest power. So what would be the highest power? The 5. So this would be a degree 5 polynomial, and that is your answer. Yes?
When you said that there can be fractions as an exponent, Does that mean the fraction has an exponent or the fraction can't have an exponent?
The fraction has an exponent. So let's go ahead and look at an example. And I didn't have you get out the expressions. We weren't going to get them out for 3 questions. I just want you to look at this. Would this be a polynomial? Yes or no?
No.
Why not?
Right.
Right here. So this is not a polynomial. Okay. Let's look at the next one. Is that a polynomial?
Yes.
Why not? Or even that one. Right. The final answers, well, most of them. So simplify each expression. So here we go. I need to simplify those. So what do you think logically you're going to do? So like, what do you think that first one should be? Just take a guess. Okay. What comes next? Minus what?
Oh, wait, no. Negative 8x.
Okay, and then
Plus 5. 7.
plus 7. Okay, now for those of you wondering, where did those come from? Basically, all you're doing is combining like terms. Now, where these numbers came from is the fact that since you're subtracting, all of these are pretty much the opposite, and then you can add. So what I suggest you do, change each of those individually to their opposites, add them together. So you get a 2x squared, a negative 8x, and then a 7. So with that in mind, let's focus on this one. And see, these don't take you long to solve at all. They actually go fairly quick. What does this one give me?
2x squared.
2x squared plus 2x
Minus 3 plus 3.
plus 3. Okay? So think you can handle those? So what are you going to do with that one? You're going to what? Distribute. So I'm just going to take the 3x times each of these. Sorry. So basically I'm taking 3 times 2, and what do I get? 6x cubed, because I've taken x times x squared. Now I'm going to take 3 times 4, and I get 12x squared. And then I'm going to take 3 times 6 and get
18x.
18x. Well, but this isn't an equation. It's just simplifying. So all you need to do is distribute on that one. We've got 2 more to go, and then we'll be done. Okay, this is one of the 2. Foil. And a lot of people think when they see something like that they need to foil. If they see something like this, they also think they need to foil. But they're 2 different problems. Okay, this one has a plus sign. That means you need to add. That one has no sign, which means you need to multiply. So make sure you understand the difference between the 2. Let's go ahead and FOIL this out. First times first gives me what? 2x cubed. Outer gives me negative 8x. Good. Inner gives me 2x squared. And last gives me negative 8. So now the biggest thing you need to do is write this in descending order. So 2x cubed plus 2x squared minus 8x and then minus 8. And we've just got one more. And we'll call it good for today. Okay, here's the one more. Now this one's a little different because it's along the same lines as the FOIL, except for I've now got 3 terms times 2 terms. Okay, so what we're going to do is we're just going to distribute each of those 3 terms. So I'm going to start by distributing the 2x. I'm going to distribute the 2x here and here. I know, it's going to right up there. So if I take the 2x squared times the 3x, what do I get? 6x cubed. 2x squared times negative 1. Okay? So then now I'm going to do the negative 4x. And I'm going to take the negative 4x times 3x and the negative 4x times negative 1. So what is negative 4 times positive 3? Negative 12, and it'll be x squared. Negative 4x times negative 1 plus 4x. So now you're going to do the same thing with the 5. Okay? So 5 times 3x is what? 15x. What's 5 times negative 1? Negative 5. So now I'm looking to add like terms together. So what will my final answer look like?
Minus 14x squared, 19x.
There you go. Okay? So, that is today's lesson. I know it's a lot of stuff, but the stuff isn't overly difficult. And so here's what you need on page 307. 16 through 48, the evens, and then 52 through 60, the evens. Okay?